Good afternoon, dear students. Uh, last practical lesson was so the previous practical lesson was the last practice related to linear algebra. We are starting a new module, analytical geometry, that would be, as I believe, it would be quite easier for you than previous. Uh, so some kind of relax maybe, and in some way we will apply some knowledge from linear algebra. So our topic for today is a straight line on a plane. So let me share my screen. So I have written down all different forms of straight line equations. So this is the general equation of a straight line. So I will remind you some different forms. Uh, uh, Remember that a and b coefficients cannot be simultaneously equal to 0. So what does this form mean? Such a form of a record. A and b are coordinates of the normal vector, vector that is um, orthogonal to the line. This is the equation of a straight line in passing through 2 points, or just 2 points from. You remember it from the school that the line. So we can write only one line through 2 points and no more. And basically, this equation is equivalent to canonical equation of the straight line, but in such case we don't know 2 points, only 1 point with coordinates x0, y0 that belongs this line, and mn are coordinates of direction vector that either belongs this line or parallel to it. So equation in the intercept forms. So a and b are x-intercept and y-intercept respectively. Equation the slope intercept that you remember from the school when drawing graphs of functions, of linear functions. But actually this intercept form is useful, uh, is convenient for such tasks as well. So the point slope form, so like the previous, but we know the slope and point that belongs this line. Parametric equation, in some situation it is useful in some tasks. And condition of parallelism of lines. So if coefficient, if we have such proportion of a and b coefficients, and if slopes are so either this or this, so dependent on the form of the equations. And perpendicularity of lines. So we remember that the scalar product of two vectors is of two orthogonal vectors, perpendicular vectors is 0. So here we are having the same situations, a and b coordinates of normal vectors. So they are perpendicular, so their scalar product is 0. The same with the direction vectors, or in slope form. And the formula of distance between a straight line and a point. So we multiply. So it is the magnitude of a scalar product of point and normal vector with the free. And with adding a free member and divided by magnitude of normal vector. Maybe any questions, any comments about equations? Or just remembering information. These equations will be always in front of us. Okay, no comments, no questions, so starting solving the task. The first task. Okay. Is it so? Do I have to zoom in the equations or not? Or it's okay for you?
It's
It's
okay.
okay for us.
Sorry? Don't hear.
There is no need to.
Okay. And I will paste once more. Task 1. So we have to write down different equations of a straight line. So firstly, the equation of straight line that passes through points M and N. So which form do we have to use? So depending on the task, if nothing else said, we just use the most convenient form, most suitable for our task. So which of them? Bogdan?
Well, 2-point form, I guess. 2 points form.
Yeah, 2 points form, definitely, because we know 2 points and we write this equation. So x minus 1 divided by x2 minus x1. And it equals y minus, so minus 2. And so y2, 5 minus 2. And if we reduce it,
I'm sorry, why we have x2 equal 2? It should be 3, yeah.
Thank you. Yeah, my bad. Thank you for your attention. And if we reduce, we will get a canonical equation of the line. So 2, 3 is a direction vector. So why such forms are almost equivalent. Okay, section B. So we know the point M, and we know the vector S. So which form can we use here in part B? So point M belongs the line. Sophia?
Canonical form.
Yeah, canonical form, definitely. So x minus 1 divided by 0. By the way, we don't basically divide by 0. It's just a form that is understandable for us. It just means that x coordinate of direction vector, in such case x, so that it is 0. And that's all what it means. Yeah, so this is the solution. Okay, and what about C? Part, so it's orthogonal perpendicular to vector n. So which form can we use? Yeah, missing this from here, but we have one similar to it. So we know the normal vector, so orthogonal to vector n, it means that it is the normal vector of straight line. Okay, so we need a general equation, but we need to, so it is a little bit modified. So, equation of the straight line given, so with the given normal vector and 1 point looks like this. And then it is reduced to general equation. So what we have here? A in our case is 3. So 3x minus 1 minus 5 y minus 2 equals 0. And let's expand brackets and reduce to the general form. Why? Just because we can do it. Just for better understanding. So to make to prove that we can reduce to any form depending on the task, on the requirements, just based on our needs. Yeah. Okay, 10 minus 3 plus 7 equals 0. So this is the general equation of the line. Any questions about this task? Comments? I guess that no questions.
Sorry, I have a question.
Yeah.
Could you explain what orthogonal mean?
Orthogonal,
It's-
perpendicular. So it is the same. So these definitions are synonyms. So orthogonal vectors and the same we can say about lines.
Okay, thank you.
More questions? I guess that no questions. Okay, moving next. Erasing, cleaning everything. Well, you saw the spoilers, but okay. Anyway, we need to solve this task. So we need to find distance between two straight lines. Yeah, we have two lines, L1 and L2. So for which lines can we find distance? Of course, for lines that are parallel. So if they intersect, we cannot do it. So basically, two ways of lines arrangement in on a plane. So either they are parallel or they intersect. Or also they can be, so it can be the same line, so they can match. And let's first of all verify that these lines are parallel. So A1 by A2 equals so 3 by 6. So one second. B1 by B2 equals -4 by -8, and it also equals 1 second. And also let's check C1 and C2. If they match, so if it equals 1 second as well, it means that these lines are the same. Yeah, we see that basically not the same, so it doesn't equal 1 second, but also verifying it. So these lines are not matching, so we can find the distance between them. How to find the distance between two lines, two straight lines? We don't know, so there is no formula to find distance between lines, basically. And any idea how to find this distance? So are the ways, so without this direct formula, but with using this one. So it is enough for now, but we just need one option. So how to solve? Your suggestions, your ideas. So no ideas. Okay, so we know how to find the distance between straight line and point. And we need to find a point that belongs any of these lines. So either L1 or L2. And then we find the distance between this point and another line. So which line do you want to take and coordinates of the point? So, okay, first of all, let's design the line. First or the second? No difference for us. It won't affect the final result, but anyway.
Let us choose first line.
Okay, so M point that belongs the first line. Okay, and we need to find its coordinates. So we need to assign x some value and then find y, or vice versa. Okay, so your suggestions.
X equals 2.
Okay, x equals 2. So then 3 by 2 minus 4y plus 5 equals 0. So, that's not the best. Not the best match, so not such convenient calculation. Maybe let's choose another point. Let's see. What about 1, by the way? So if we, so of course, take care of convenient calculations as well. Of course, you will get the same result, but do you want to calculate a lot of fractions? I guess that not. So if we assign x1, so what we have 3 minus 4y plus 5 equals 0. So it means that y equals 1 or equals 2. So, and that's it. And I will write better. Yeah, so the better appearance. So found the coordinates of M point. So 1, 2. And now calculating the distance between M and L2. So with using this formula, so A for AL2, so X, 6 by 1 minus 8 by 2 and minus 13. And by the way, this normal vector has so good coordinates. So 36 plus 64, so it's easy to calculate. So nice example. So what we have here? 6 minus 16 minus 13, so 23. Okay, I can write here like this for now, and here square root of 100. So 23 by 10. So this is the distance. And for more understandable way, in decimal form, 2.3. Any questions about this task? Questions, comments? Okay, as I see, no questions, so moving forward. So task 3, it's quite big, so we will have to do a lot of, here a lot of work to do. What's going on? And finally, we will have to build graphs even. What's going on? Understand why. So print screen doesn't work, but it worked before. Just forgot to click here. Okay. So moving to equations. So first of all, we need to find slope of a straight line L1 and its y-intercept. So to do it, we basically need to write a slope-intercept equation. Okay, so we're writing this equation. So y equals minus 4x. Yeah, and this is L1 line. So minus 4x plus 8. So the slope is minus 4. And what about y-intercept? Y-intercept. So can we find it from this equation, or do we need first need to find intercept form of the equation, or we don't have to do it?
Isn't it?
Sorry, I don't hear.
Isn't it 8?
Yeah. So B is the y-intercept that you remember from the school. So 8, correct. So part A is done. Moving to part B. So we need to find equation in intercept form for both straight lines. So this is the intercept form. And so for L1, doing it. So first of all, so we are moving 8 to the right part. And now dividing this equation by 8. So 4x by 8 plus y by 8 equals 1. And finally, So L1 x by 2 plus y by 8 equals 1. So it will be easy for us to build the graph of this straight line. Then for the same for the L2. So x minus 5y it equals 2. So x by 2 minus 5 by 2 5y by 2 equals 1. And then so x part x addend is not changed, and we are rewriting this so that only y here stands here, and moving over so numbers to the bottom. So 2 by minus 2 by 5. So just to know intercepts when building the graph. Basically L2 equation. Well, so intercept equation final form minus 0.4 equals 1. So done part B. Any questions for now? Comments or no? Questions and comments. Okay, moving next. So we need to find an intersection point of n. So n intersection point of straight lines L1 and L2. I have a question: how to solve it? How to find this point?
We need to say that both lines are equal to each other.
You are almost right, but not fully. So you suggested to put equality between these left parts, right?
Yeah, or we can also solve the system of the equation.
Yeah, we need to solve the system of these equations so that we know it from school and now reminded. So solving system of linear algebra equations. So nothing new from you. You already can do it. So now just solving it with the substitution. So x equals 5y plus 2. And so for this. Minus 8 equals 0. So plus y, of course. Plus y. No, I will rewrite it. So that's basically not a paper. So finding y. So 20 y plus 8 plus y minus 8 equals 0. So 8 so constants are eliminated, so y equals 0. And it means x equals 2. So found the point n coordinates 2 and 0. And that's it for this part. Moving next. So we need to find to write down the equation of straight not point but line. That was a mistake, and I also will have to fix it there and copy pasting. So just a moment. So fixing this. Line here and line here. Okay. So for now everything is correct. So we need to find the equation of straight line L3. We don't know this line, but we know that it passes through the. It is passing through the point M, and it is parallel to straight line L2. So what can we do with knowing such information? Yeah, and I will copy and paste this equation, not to forget. So, yeah, and point M, by the way, minus 4, 7. So enough data for us. So any ideas how to solve? What can we find from this equation of L2 from the general?
Well, we can find the slope.
We can find slope, but we not only slope. So so without modifying this equation, what can we find?
Normal vector.
Yeah, normal vector. So normal vector of this parallel line has coordinates 1 and -5. And what can we say about L3? That we know that it is parallel to L2. So
They are proportional.
they're proportional, but they also can be the same. So we can use n3. So we can use n2 as n3 as well. So like so normal vector for L3. So their proportion will be equal to 1. So it is enough for us. So we know the normal vector and we know the point that passing. So writing down the equation. X plus 4 minus 5 y minus 7 equals 0. And if we expand the brackets, we will get the equation of so the general equation of the straight line x minus 5y plus 39 equals 0. So this is the equation of line L3. Okay. Any questions about this task? Any comments?
No.
Okay. So moving next. So we need to find now a straight line L4, the same, passing through the point M, and it is perpendicular to straight line L2. So L3 was parallel, but this is perpendicular. So taking this information. And don't forget, so write this condition. By the way, is it enough visible for you enough or not? So such indices and so on.
Yeah, it's fine.
Okay, so I don't have to zoom in. Okay, and how to solve this task?
We
So,
have a formula for this.
Uh,
No, you wrote it, I think, in the previous task where it's a
well,
times
yeah, we need we will need this normal vector for L4, but we need to find it first of all. And how to find it? Because for L3 it was known, but we need to find for N4. For L4, and this vector is N4.
well, we can use the formula where a times x minus x0 plus b or minus b times y minus y0 equals to 0 now.
So we will use this formula. So we used it
Oh,
also
okay.
in this part, but we don't know
Yeah,
the normal
okay.
vector. How to find it? So any ideas? Bogdan?
We need to use the condition of perpendicularity of two vectors, but I forgot it.
Well, basically, now we don't need to use it, but we need to find one more. So, yeah. So we need to find the normal vector of it, and okay. So no, we don't have to use the condition of perpendicularity, but we need to rewrite the equation of L2 to another form. Which form? So no ideas. Okay, we will rewrite it in the canonical form, and we will get the direction vector of L2 that is perpendicular to N2, and it will be the normal vector of L4. So basically, so I will just remind you. So this is the line. This is the direction vector, and this is the normal vector. So according to this, we know that normal vector of straight line 4 matches direction vector of line L2. So we will rewrite this equation into canonical form, and then we will find the direction vector. So let's start doing it. So x minus 2 equals 5y. So moving to the right. And now, and now I'm dividing it by 5, or no. Basically, what I can do, I will just move. I will divide this this part by 5. Now, how to explain for you it for you correctly? So just in canonical way, x minus 2 divided by 1, and moving 5 here, so y by 1/5. So what I have. Or finally, for more understandable way, so x minus 2 by 1 equals y divided by 0.2. So this is the normal vector of line L4. So it will equal 1 and 0.2. And now we know we have all information to build the equation. So x plus 4 plus 0.2, 0.2 actually, but never mind. So y minus 7. And it equals 0. So this is the equation of line L4. Now let's improve it a little bit because we will have to draw the graph of this line. So x plus 4. First of all, let's expand. Okay, x plus 0.2 plus 2.6. And now let's multiply it by 10, by the way. Oh, we don't need to multiply by 10 just to get all parts whole numbers. So we need to multiply by 5. It will be enough. So 5x plus y plus lucky numbers 13 equals 0. So this is the equation of line 4 as well, but we multiplied both parts. Any questions about this task? No questions. Okay. So now moving to the section F. We need to find distance between point M and a straight line ML2. So we're using this formula. So let's, by the way, so it doesn't want to copy and paste. Okay. We'll rewrite it in our own. So ML2. So what we have. Yeah, of course, it will be nice to copy and paste to see always the conditions that we need. Okay, so minus 4 by 1, minus 7 by 5, minus 2. And 1 plus 25. So what we here have minus 4, minus 35, so minus 39, minus 2, minus 41. So minus 41 by square root of 26. And basically what we have, 41 divided by square root of 26. So leaving it in such way. Any questions about this part? I guess that no questions, but nevertheless. Okay, now we will build graphs, and after that we will have a break. So L1, y equals, by the way, let's use in intercept form just to demonstrate. So x2 plus y by 8 equals 1. So this is L1. So we can see so x-intercept, y-intercept. So they match. Everything is all right. Then x by 2 plus y by minus 0.4 equals 1. So here we received the by the way, also, so x-intercept for this line L2, and by the way, we have so we found the point of so intersection point of these lines, so n. So here it is on the graph. Then L3. Okay, just to save our time, we won't do a lot of manipulations, and we'll just write the general form. Where is it? Ah, here is the line L3. So here it is. Such scaling. So it's such sensitive scaling. I don't like it, but a good demonstration of graphs. Okay, and now building the last graph. So for L4, 5x plus y plus 13. It equals 0. So what we have? Yeah, and point m point, so minus 4 and 7. Label m, so minus 4. So here is the so the point that belongs L3 parallel to L2 and L4 perpendicular to L2. So here is it. Here it is. Oh, by the way, yeah, So as we can see, lines L1 and L4 are intersecting, so it means also that lines L1 and L2 are not perpendicular. So, but here it is not clear enough from this drawing. Okay, any questions, comments about this task? Or no questions?
No questions.
Okay, but and also I will share a useful link with you. I guess it would be nice for you just to verify some results and build beautiful graphs. Okay, and now let's have a break for 5 minutes and then we will continue working. Okay, let's continue. So cleaning the board. So-called board. So exercise 4. So we need to examine if lines L1 and L2 are parallel or they intersect, and if so, if they're parallel, we need to find distance between them. If they intersect, we need to find intersection point. So let's start with part A. So A1 by A2. So 1 second. B1 by B2 equals 1 by -2. So it means that L1 and L2 are not parallel. So that they're intersecting. So finding their intersection point. So x plus y equals 1, 2x minus 2y equals -1. So solving by the Gaussian method, but without writing in matrix form. So just 2x plus 2y equals 1. And this equation without changes. So now eliminating x. So eliminating y. So what we have? 4. Sorry. So 4x. Yeah, forgot that it's 2 here. So 4x equals 1. And y equals 1 minus x. So x equals 1 by 4 or 0.25. So y equals 3 by 4. And so 0.75. By the way, let's verify. So correct. And here, so 1.5 minus 0.5 minus 1.5, so -1. Okay, so here is M0 coordinates 0.25 and 0.75, but we can write it like a regular fraction, non-decimal. And now so we need to find to check so part B. As we can see here, so for case B, one equation is in canonical form and other is in general form. So we need to rewrite it to the one form. So what can we do basically? So we don't need so any special form. So for our convenience, it will be. So what do you suggest? By the way, I want to hear your opinion. How to simplify our calculations, our life. So this part of life related to solving current task. So any ideas? No ideas? So we need to reduce to one form. Which of them? Okay, as I see, no ideas. So I suggest eliminating these fractions. So I can multiply the second equation by 2. And then it will be rewritten into the general form. So x plus y plus, not good, plus 1 equals 0. And it's obvious that L1 and L2 lines, they are parallel. So A1 by A2 equals 1, B1 by B2 equals 1 as well, and C1 by C2 equals -1. So it means that this it is not the same line, so lines L1 and L2 are parallel. Now we have to find the distance between L1 and L2. And what you remember how to solve it, how to find the distance. Your ideas? So no ideas.
We need to find a point that belongs to line L1.
Either L1 or L2. Okay, so let's find the point M that belongs L1. Okay, which coordinates do you suggest to select? So basically, the equation looks quite enough convenient, so without any fractions calculations. So which point do you suggest?
1.
Okay, so x will set in x to 1, x0, so y with index 0 will be equal, so 1 minus 1, and it equals, it will be equal to 0, so just let's skip it. So yeah, it's so good point, so easy calculation. So m, so the distance between these lines will be calculated as distance between M point and L1, L2, sorry. So we need to find the next. So the magnitude of, so A1 multiplied by x, oh, no, A2 multiplied by x0, but anyway, they are equal. Plus 1 multiplied by 0, and C2 equals 1, plus 1. And 1 plus 1, actually. So what we have, 2 by square root of 2, and we can even simplify, so just not to use irrational coefficients at the bottom, so square root of 2. Any questions about this task, or no questions? Okay, no questions. So now moving to the last task for today. Okay. So now, so we have vertices over the triangle. We need to write down equations of the median AM and the height BK. For our convenience, let's first of all write. So let's draw the triangle. So it is any triangle. We don't know its appearance. A, B, and C. So median AM, so point M is here, and the height. Let's draw it. So I guess it is almost perpendicular. Let's think that it is perpendicular. So BK. Yeah, and also let's draw this line as well. Okay. So how to solve? First of all, let's find median AM. So it's equation. How to solve? Basically, that's not only one step. So how to solve? How to find median? Just describe steps for now. The algorithm of solution. Sophia?
Maybe first of all find the coordinates of the point M.
Yes, and then?
And then use 2-point form equation.
Yeah, correct. Okay, so who remembers how to find the median? So M point coordinates. I know that you remember.
X B plus X C and divide by 2.
Yeah, and the same with the Y part. So B plus C 4 by 2, and it equals 2. Yeah, and X YM as well. Uh, 4 plus 2, 6 by 2, and it equals 3. So found M coordinates 2 and 3. And now writing down the equation of AM. Okay, let it be L1. So if we continue this straight line, and this can be continued as well. So it's infinite. We know it. So x minus, so x plus 2 and 2 plus 2 equals y plus 3 and 3 plus 3. So finally, x plus 2 by 4 equals y plus 3 by 6. So here is the equation, and I won't ask you how to find the length, because it's the square root of difference between these points. So square root of sum of squares. So 2 plus 2 in power of 2 plus 3 plus 3 in power of 2. Yeah, basically am. Let's write here. Distance between points, yeah, so 2 plus 2, 3 plus 3. So 4 plus 36, yeah, it's not good enough. So not everything will be can be evaluated here. So 4 by 10, by the way, and this is finally it equals 2 square roots of 10. Okay, moving next. So now we need to find the coordinates of L2. Yeah, any questions?
Sorry, why is it 4? I think it should be like 2 plus 2 is 4,
Yeah,
and 4 to
thank
square
you.
is 16.
Thank you. Yeah, that's nice catch. Your attention. So I'm already thinking about my lunch, so that's why it's so hurrying. So oh yeah, 52. So it's yeah, equals 2 square roots over 13. Sophia, do you have a question?
Yes, about 2-point form. Why you said that it should be plus? Like, I
So
guess it's in
but
form
we have
it's
minus
minus.
before coefficients. So so as x1, I selected x a, and for x2, xm. So that's why, yeah, so minus xa, so plus x2 it means.
I got it, my bad.
Yeah, be very attentive with the signs, and when sending your individual tasks, also make sure that you haven't confused anything. By the way, if I'm not mistaken, you have some time to send, so to recheck and to edit. Okay. So done with the median. And what about BK? So, any ideas? So we remember that BK is perpendicular to AC. So any steps? So
Maybe we could find line AC.
yeah, first of all, equation of the line AC. Okay. So AC. Then the next step. So what if we find AC? What else can we receive? So what will we need to find BK?
Normal vector maybe.
Yeah, normal
sure.
vector, and we will find it from equation of AC. Correct. So with the normal vector and coordinates of B, we will find the so we will write down the equation of L2, and how to find the length of BK. What we also need to find.
Point K.
Yeah, okay, so basically this is such kind of algorithm. So first of all, finding AC. So AC, yeah, okay, I will write it in such way, LAC with such index. So x plus 2 by minus 1 plus 2 equals y plus 3 and c 2 plus 3. So here we have 1, and now we need so to find our normal vector, we need to find to write in general form. So x plus 2 is okay, and the right part must be multiplied by 5. So basically both parts will be multiplied by 5. So 5x plus 2 equals y plus 3. So 5x minus, yeah, okay, let's write it, plus 10 minus 1 minus 3 equals 0. And finally, five x minus y plus 7 equals 0. So what is which coordinates are over the normal vector?
Five and minus 1.
Yeah, 5 minus 1. Okay. So now we have everything to write the equation of L2. By the way, so if we have normal vector of AC, so now we know the direction vector of okay, I will write so it equals direction vector of BK. So which form of the equation will we write? Will we use? Just duplicating coordinates in order not to scroll up every time. So we know direction vector, we know the point. Okay. So it seems that you forgot it. So canonical equation. So everything we have for that coordinates of the point that the line passes through and the direction point. So x minus 5, yeah, basically it's equation of bk. X minus 5 divided by 5. And it equals y minus 4 divided by minus 1. So that's it. Found the equation of bk. But also we need to find the lengths and first of all we need to find k. How to find k?
It will be intersection of AC with BK.
Yeah, it will be intersection, so it means that we need to find to solve the equation system for these lines. And first of all, let's rewrite bk equation to the general form because it's easier to solve for us. Minus 5 or minus 25 equals 0. Okay, and now let's write the equations. So 5x minus y equals minus 7. X plus 5y equals 25. Okay, let's solve it with the substitution method. I guess it will be easier for us, so more convenient in such case. X equals 25 minus 5y, and correct it a little bit. 25. And 5, yeah, just substitute. Okay, so 125 minus 25y minus y equals minus 7. Then minus 26y equals minus 132 minus 132. So y equals 132 divided by 26. Okay, so not so convenient, but let's calculate. So 66 by 13, and basically that's it that we can do, and it is almost so it's almost 5, by the way. Then so x equals 25 minus 5y. So 25 minus oh my goodness. Oh. So 25 by 13, by the way. 335, 325 minus 330. So minus 5 by 13. So found coordinates of K. They are not so good, so convenient, but we have what we have. And now, so finally, what we need to find the length of BK. Oh goodness, 4 minus 66 by 13. So 65, 70 in point of 2 plus so 69 plus so 52 minus 66, so 14 in power of 2. And moving 1 by 13 out of square root. By the way, 14 in power of 2. 196. Okay. So good number. Let's extract. Oh, what we can extract. So can we divide it by 16, by the way? No, we cannot. What? Yeah, we can divide it by 4. So I can move it out of square root. So, and it will be equal 1,274. Okay. What else can I do? It seems that nothing can be done, but let me try to check. Maybe we can evaluate such square root. No, we cannot do it. Okay, so let's remain it as it is. So it, as I see, it is not divided by 9, so no squares. Yeah, maybe it can. Yeah, it also can. Yeah. By the way, let's try to divide it by 7. Let's try to divide it by 49. Okay, 2. No. So 49 by 26. So moving out as much as possible. So that's what we have. And this is the length. But yeah, if we calculate it, finally, okay, let's let's leave it as we have. This is the final answer. Any questions about this task? This task maybe, or no questions?
No question.
Sophia? Yeah?
I don't have questions about this
Ah.
task, but will we have individual home tasks for the second module?
For the second module as well, yeah, I will ask a lecturer about it, maybe to unlock it for you. You will have individual tasks for everything, don't worry. Okay, more questions? Okay, I see that no questions. By the way, I organized a little bit practical lessons in on DL, so now it is now it is more compact. Now I put it into the folder in different folders. I will add more files here with new practical tasks. So just for your information. But anyway, you will find everything. So have a nice day. Stay safe. Thank you for your attention.
Thank you for the
Bye.
lesson. Goodbye.
Thank you.
Thank you. Goodbye.